Today you'll be solving quadratics using the quadratic formula. So the discriminant of ax plus bx plus c is the value of b squared minus 4ac. And we have some different things we can do with discriminant. If my discriminant is bigger than 0, meaning it's a positive number, then that means the number of solutions that I have is 2. And the reason why you have 2 solutions is if you were to graph something with a positive discriminant, notice you have 2 solutions. You have this guy and this guy, meaning you have 2 places in which the graph crosses the x-axis. If we were to look at an example, let's say we have x squared plus or minus 2x equals 0. Well, the first thing you would do is you would identify your a, b, and c. Okay, so in this case, a is 1, b is negative 2, and c is 0. And when you plug it into the discriminant, we have negative 2 squared minus 4 times 1 times 0, which gives us a discriminant of 4. And it's a positive number. And if we look at the graph of x squared minus 2x, notice it has 2 places in which the graph intersects. If we had a discriminant that equals 0, well, that means we have one real solution. If we take a look at an example, let's say we have x squared minus 4x plus 4. Well, if we look at its graph, notice that the graph only touches the x-axis in one place, and that's it. Remember, if we were to find the discriminant, we would first identify a, b, and c. So in this case, a is 1, b is negative 4, and c is positive 4. When we plug that into our discriminant formula, we do get negative 4 minus 4 times 1 times 4, which will give us a discriminant of 16 minus 16, which is 0. If we look at our third option, if we have b squared minus 4ac is less than 0, meaning the discriminant is negative, then that means we have no real solution. There's still a solution, but it isn't a real number. And if we look at an example, notice we have x squared minus 2x plus 2. Well, if we were to graph that, we would have a graph that does not cross the x-axis, as we can see in this picture. If we were to figure out what the discriminant is, notice we have a is 1, b is negative 2, and c is positive 2. And if we were to plug that into b squared minus 4ac, we do get a negative number, negative 4. So for our first example, we're going to evaluate the discriminant to determine the number of real solutions, and x squared equals 6x plus 5. Well, in order for us to even use the discriminant, the first thing we have to do is we have to move everything to one side, and we want to have 0 on one side of the equation. And if it were me, I would suggest that you leave your x squared term as a positive number. So when we subtract the x and the 5, notice we do have x squared minus 6x minus 5 equals 0. Now, we can use the discriminant. Remember, your a value is 1x squared, your b value is negative 6, and c is negative 5. And I would use a calculator from there. And notice we get a discriminant of 56. And because that's a positive number, that means we have 2 real solutions. I want you to take a minute or 2 and try the 2 example u-tries. Hopefully you find the first example to have a discriminant of negative 47, which means there's no real solution, and the discriminant on the other example, the later, 0, which means there's 1 real solution. So let's look at the quadratic formula. Well, you might ask yourself, where does it come from? Now, I'm just going to show you where it comes from. You don't necessarily need to write this stuff down. So the first thing we're going to do is we're going to essentially complete the square. We get quadratic formula by doing this process. So remember, the first step in completing the square is to move the constant to the other side. So we're going to subtract both sides by c. So now we have ax squared plus bx equals negative c. After that, remember we have to ask ourselves, is the leading coefficient 1? Well, in this case it is a, so we have to divide everything through by a, so we have a 1x squared. Okay, so the next step is to take our middle term, b over a, we're going to divide by 2, which is the same as multiply by 1/2, we will square it. That is where this b squared plus 4a, b squared over 4a squared comes from. It's up here in the thinking bubble as we completed the square. Okay? From there, we factor the left-hand side. Remember, it will factor to whatever b divided by 2 is before you square it. So this, I need a different color. This value in here before we square it, which is b over 2a. And notice on the right-hand side, we found a common denominator with these guys. So the common denominator would be 4a. So you actually multiply that negative c over a by 4a. Okay, now remember, to solve by completing the square, the next step is to square root both sides. And when I square root the right side, I have to include that plus or minus. The next thing we will do is we will move the negative b over 2a to the, well, no, sorry, we simplified the square root. So remember, I'm thinking in my brain, the numerator is the square root of b squared minus 4ac, and the denominator is the square root of 4a squared, which is 2a, which is where that came from. Now, because I have like denominators, when I move everything over, all we do is we write it as one fraction, and there's our quadratic formula. And if you know the song, you can sing the quadratic formula song. So if we look at our next example, notice we're going to solve the quadratic by quadratic formula, and we're going to leave our answer in simplified radical form. In here, unless you have a story problem, you will leave it in simplified radical form. Okay, so let's look at the first one. The first thing you'll want to do is you'll want to ask yourself, is my equation equal to 0? And in this case, yes. The first step is we're going to find the discriminant. This is going to tell me whether or not I can stop or I can keep going. So our discriminant, we're going to take the b value, 4 squared minus 4 times a, which is 1, times c, negative 3. I would use a calculator and type it in the calculator exactly like I see. Okay? In this case, it does end up being 28 because you have 16 plus 12. Second step, you're going to use the quadratic formula. And now we're just going to plug and chug. Okay, so x equals negative 4 plus or minus. Now, we've already found b squared minus 4ac in step 1. So all I need to put under the radical is the 28, 2 times 1. Now, remember you have to rationalize that square root of 28. So what I'm actually thinking in my mind, I'm doing a thinking bubble off to the side, and I'm doing a factor tree for 28. Now remember, in order to come out of the square root sign, you have to have 2 of the same number. And we've broken down 28, we've broken down 14. Notice we have a pair of 2's here. So we can say x equals negative 4 plus or minus 2 square root 7 all over 2. Now I have to ask myself, is this reduced as low as it can go? And the answer to that would be no, because if I look at this combination and this combination, every single number can be divided by 2. Okay, so negative 4 divided by 2 is negative 2. 2 rad 7 divided by 2 is just square root 7. And then the denominator is 1. So here is our answer. If we look at the next example, is it an ax squared plus bx plus c equals 0? Well, the answer to that is obviously no. So we have to subtract the x so that it is on the left side. So 2x squared minus x minus 4 equals 0. And we're going to do the same steps as we did before. The first thing we're going to do is we're going to find our discriminant. So b squared minus 4ac. So our b is -1, a is 2, c is -4. And I would type all that into a calculator exactly like I see. It does give us a discriminant of 33. Okay. Second step, you're going to use the quadratic formula. Okay, so opposite of b would be +1 plus or minus the discriminant we already found to be 33 all over 2 times 2, which gives us 1 plus or minus the square root of 33 all over 4. Now, I'm going to ask myself, can I break down 33? Well, if we do a factor tree for 33, we just have 3 and 11, which has no like pairs. So here is our answer. Now I want you to take a minute or two and try the 2 example U-tries. So hopefully you'll find the answers for the first example you try to be -1 and -3. Now remember, if you can square root a perfect square, you need to do so, and then you need to give me 2 numeric answers. It is not sufficient to say -2 plus 1. You have to tell me the -1 and the -3. For the problem on the right, or letter B, you should have had 3 and -1/2. And again, it is not sufficient to say 5 plus or minus 7 over 4. You have to give me those 2 numeric answers. Let's look at a few story problems. In the first example, we have the jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that the band charges for each CD. The following equation models the profit of the fundraiser. What is the least amount in dollars you can charge for a CD to make a profit of $200? So I want to know the smallest amount of money you can charge to make a profit of 200. So profit of 200, which letter is that going to go into? Well, there's a clue in the second statement. It says the total profit P depends on the amount of X the band charges. So that means we're going to replace the P with 200. Now we're going to solve for X. Remember, our goal is to use quadratic formula. I don't like looking at a -x squared, so I'm going to move the entire right side of the equation to the left-hand side. Once we have this step, we're going to find the discriminant. Remember to use the calculator for your discriminant, 304 should be Ed. And now we can use quadratic formula. So X is going to equal the opposite of B, in this case is +48, plus or minus the square root of 304 divided by 2 times 1. And honestly, from here, it's probably easiest just to go to a calculator. Now in this case, it is okay to not leave it in exact form because we are looking for a dollar amount. So if we take 48 plus 304 square rooted over 2, let's see what that gives us. This value, when I use my calculator, gives us $32.72. Now let's find the other possible solution, 48 minus the square root of 304 over 2. And let's use a calculator to find that value. So which of these values gave us the least amount? Well, the $15.28. So $15.28 is the least amount you can charge to make a profit of $200. So now let's look at the other example. Notice it says we're gonna, oh, my stuff is all going in strange places. You hit a golf ball into the air from a height of 1 inch above the ground with an initial vertical velocity of 85 feet per second. The function h equals negative 16t squared plus 85t plus 1 over 12 models the height in feet of the ball at time t seconds. Will the ball reach a height of 115? Okay, so the 115 is our height, and we're going to put that in place of h. Okay? Now, again, I do not like to look at a negative t squared value, but because we have some weird fractions, I'm just going to go ahead and move the 115 over. So our quadratic is 0 equals negative 16t squared plus 85t minus 1,379 over 12. All I did was take 1 divided by 12 and then subtracted 115 in my calculator. If I'm using a graphing calculator, I just push math, enter, enter, and it will put it into a fraction for me. From here, we're going to do the discriminant. Okay, so when we do the discriminant, notice we'll have 85 squared minus 4 times negative 16 times negative 1379 over 12. And this does give us, when I use a calculator, negative 129.67. Well, if our discriminant is negative, what does that mean? Remember, it means no real solution. Okay, so because the discriminant is negative, discriminators, that's autocorrect. The discriminant is negative, meaning there is no real solution, so the ball will not reach a height of 115 feet. And what do you feed baby parabolas? Quadratic formula. Waka waka.